So we're going to take a look at y is equal to ax squared. Now, when we go and type in ax squared, we get this nice slider. Now we're going to click the slider, and it's going to give us something interesting. It's going to give us the base graph of y is equal to x squared. So let me just type that in so we have that. Y is equal to x squared. Now, the blue graph is our original graph, and then this new graph with a is equal to 1 is our red graph, which is going to sit underneath our blue graph here. So now, what happens when we have an a value that is bigger than 1? So what actually happens? So if we go and choose our a value to be bigger than 1, so let's say it's 4, right? Basically, what happens is our graph gets skinnier, all right? And because it gets skinnier, we call it stretched. So essentially, when we take a look at our graph, if we just ignore the sign, the graph gets stretched, gets pulled taut, gets smaller than the original base graph of y is equal to x squared. So when I go and stretch my values, I end up with a skinnier graph, okay? We call this compressed. Not compressed, stretched in a curve, okay? So we say that the curve is stretched in this case. Now, my question for you is, ignoring the sign, what would happen if our value of a was between 0 and 1? So let's go and change this to say 0.5. As I get closer and closer to 0, my graph gets closer, gets fatter and fatter, right? We say, in this case, so when we basically have our value of a being bigger than 0 but less than 1, we end up having our graph being compressed. As long as we ignore the sign, the graph is compressed by a factor of a. All right? Now, if we take a look at the stretch thing, we say that the graph is stretched by a factor of a. So, here's an example. Suppose I am looking at y is equal to x squared. Y is equal to 2x squared, right? So we have that black graph there. When we look at that black graph compared to y is equal to x squared, it's skinnier. So you could literally say that this graph is stretched by a factor of 2. So essentially what we're doing is we're multiplying each of the numbers for the y values of each graph by a factor of 2. Okay, now if we do the same for this type of equation, y is equal to let's say 0.5x squared. Our graph is going to be not stretched, but this time it's flattened. So now it's compressed by a factor of 0.5. So all we're doing is taking the 0.5 and multiplying by each of the y values to get those things. All right? So it's very similar to what we did before, and that's it. Okay? The only thing that we have left to look at is what happens when we have a negative value. Ready? So here's what I want you to do. I want you to watch the red graph, and you'll notice if I have a negative value, all of what we did here still applies, but if it's negative, our graph opens down. If our graph is positive, if the a value is positive, then we know our graph opens up. That's all you need to know. Okay? All right, back to the lesson.